Okay, today we're going to limits and continuity, limits at infinity. This is part C. Good news, this actually is a very easy lesson, hopefully. A lot of stuff we covered in Algebra 2 and some of the concepts we covered earlier this year. But infinite limits involve allowing x to go to infinity. You always solve these the same way. You write the problem as a fraction, and then you look at the highest degree term in both the numerator and denominator. We've done that before. If it's already written as a fraction, your job is pretty easy. So something like this, I've got limit as x goes to infinity, x squared minus 3x plus 7 over x cubed plus 4. Well, we'll look at an example like that. So remember, we ignore everything but the highest power on the top and bottom. So here, something like this, if I've got limit of x squared over x cubed, well, this is going to reduce to 1 over x. So my limit as x goes to infinity of this is going to be 0. All right, so as x goes to infinity, what are some of my rules? Okay, if the top has a bigger power, then there are two possible answers. It can be either infinity or negative infinity, and we'll look at some examples of that. If the bottom has the bigger power, then the answer is 0. It means that the bottom is going to infinity, and so the answer is going to 0. And if the top and bottom have the same largest power, the answer is the coefficients for those two terms. So this is similar to some stuff we had done earlier in this class. Let's take a look at some examples. Here I've got the limit as x approaches infinity of 4x squared minus 7x plus 1 all over 3x minus 1. Well, what do I have? I've got the limit, if I just look at the highest powers, of x squared over 3x is equal to the limit of 4x over 3. So that's 4 thirds times infinity, which is going to go to positive infinity. Now, technically, you could write that as does not exist. I prefer positive infinity, so you know where it's going. It's not really a number, but that's more descriptive than does not exist. But technically, the limit doesn't exist. Let's look at this one. Here I've got the limit as x approaches negative infinity of x cubed, 8x cubed plus 3 over 7x cubed minus 14x squared plus 3x minus 9. Well, we're just going to look at the highest power. That cancels out, and just simply the constant 8/7. Here I've got the higher power in the numerator. So I've got 3x to the 4th minus 3x all over negative 3x cubed. Well, that's going to be x over negative 1. The limit of negative x as it goes to infinity is negative infinity. Again, technically it does not exist, but I prefer negative infinity because you can see which direction it's going there. All right, let's take a look at some more here. I've got 4x to the 4th plus 3x squared plus 2 all over 1 minus 3x cubed. Well, what are the highest terms? I've got 4x to the 4th, and I've got negative 3x cubed. All this other stuff becomes insignificant as these powers get larger and larger. So I've got 4x cubed over negative 3x squared, 4x to the 4th all over negative 3x cubed. The x cubes cancel out, and I've got 4x over negative 3 as x goes to infinity. That's going to be negative infinity because we're going towards negative infinity. So that's positive infinity, does not exist. Here I've got 3x to the 5th plus 7x squared minus 9 all over 4x cubed plus 7. The highest terms, 3x to the 5th all over 4x cubed. I've got 3x squared over 4 as x goes to negative infinity. Well, negative infinity squared is positive infinity, but that still does not exist. What if the problem is not in fraction form? Well, then simply rewrite it in fraction form. So if I have something like this, limit of 2 to the negative x power as x goes to infinity. Well, 2 to the negative x is the same as 1 over 2 to the x. And then 1 over 2 to the infinity, well, it's 1 over infinity. That's going to equal 0. So the limit of 1 over infinity is going to be 0. How about the limit of x as x approaches infinity? Well, x over 1, we could write it as a fraction like that. It's simply positive infinity over 1, which is positive infinity. Again, does not exist. So once you get the hang of these, they're really not too hard. What about something like this? I've got limit as x approaches infinity of x over x plus 1 squared minus 4. Well, we're going to take these separately. So I've got this first one here, I've got x over an x squared, and here the limit as x approaches infinity of 4. It's just a constant. It stays 4, so minus 4. So here I've got 1 over infinity minus 4. Well, that's 0 minus 4 is negative 4. All right, look, well, that's a little bit tricky here. So limit of a constant is that constant. So limit of 3 of 3 to the negative x as x approaches negative infinity. So I'm going to put the exponent in the denominator. So I've got x as it approaches negative infinity, 1 over 3 to the x is equal to 3 over 3 to the negative infinity, which is equal to 3 to the positive infinity, which is positive infinity. Again, does not exist. All right, that's where we're going to end this lesson, and now we're going to switch over to the in-class worksheet.